Okay, second part of the covalent worksheet. These are the solutions. I'm going to do them quick. I changed, if you'll recall, 8 and 9, and here is how they should actually work now. Oxygen, 6 electrons, and if it reacts with fluorine, and fluorine has 7 electrons. Each of these fluorines has 7 electrons, group 17, 7 valence electrons. Oxygen has an octet, and each of the fluorines has an octet. We could write that in lines like this. Don't forget your unshared pairs. And looking at this, we can see that oxygen comes first, fluorine comes second. So that's how we're going to actually write them in the formula. Oxygen F2, and we call that oxygen dichloride. Oh, number 7, it was the one I changed, okay. I've already done 9, and I'll do number 7. Put nitrogen and hydrogen. Nitrogen, group 15, 5 electrons. Hydrogen, group 1, 1 electron. Is nitrogen happy? It has 8 electrons, and each of these hydrogens has 2, so yes, they are happy. This structure looks like, oops, I'm drawing lines. This is what I want us to do now. And one unshared pair there for nitrogen. You know this is ammonia. That's the common name. I'd like you to try to name it per the naming conventions I gave. And that would be nitrogen trihydride. Odd, but that's what we'll do for now. Moving along, we're going to get into some more complex ones. I'm going to pause here. I'm going to do these. Well, I'm going to start you off actually. Hydrogen can only form 1 bond. Oxygen can form 2. If we're going to try to bond all 4 of these together, we know that the oxygens are going to have to be in the middle. Okay? And I'll put the electrons here and you'll see it. Same down here, we have carbon. It can form 4 bonds. Hydrogen can only form 1, and chlorine can only form 1. So we know which one's going to be in the middle here. It's going to be the carbon. And you can have your hydrogens here and here, and you can have your chlorines here and here. I'll add the electrons, and I'll be back in just a second. Okay, have these solved for us. Again, we put the oxygens in the center here on this, this one right here. And oxygen has 6 electrons, 1, 2, 3, 4, 5, and 6. Okay, and this oxygen has 6 as well. 1, 2, 3, 4, 5, and 6. Here's a single bond. Here's a single bond. Here's a single bond. This whole thing is bonded all together, just like that. I'm going to go ahead and erase that. I didn't like drawing over that, but I don't know how to back up. So anyway, this is going to look like that. When we draw it as lines, it looks like this. And here is the formula right here. And we're going to name this thing dihydrogen dioxide. But we really know that its common name is peroxide. Here's the solution for the next one. Right here, carbon in the center, surrounded by 2 fluorines, 2 hydrogens. Chlorine has 7 valence electrons. This is the dot and stick structure here. Here is the formula CH2. Oops, sorry. CH2, Cl2, carbon dihydride dichloride. Now that's not its real name, but that's how I want you to try to name these things. Moving on to these guys, I am going to show you very quickly, even though these are in the introduction to double and triple bonds. I'm going to pause it here, and I'm going to do our solution. Okay, what you're going to see here is, generally speaking, oxygen is a double bond. You can see that each oxygen commits 2 electrons, still has 2 unshared pairs, and that's what we can look at right there. We can look at it right like that. Nitrogen has a triple bond. Each nitrogen donates 3 electrons and forms 3 bonds. That's a triple bond, and it still has 2 unshared pairs. Formula for both of those, O2 and N2. Stopped because I wanted to actually do this one right here. Carbon plus 2 oxygens. Here we go. Carbon in the center. Carbon has 4 valence electrons. Hang on a second. The one I wanted to do was right here. Carbon, 1 oxygen, carbon monoxide. Carbon, 4 valence electrons, right? Oxygen, 6 valence electrons. 1, 2, 3, 4. I'm going to donate 5 and 6. This carbon is going to actually change these electrons around so that it has an unshared pair here, and it donates 2 to the bond. That's still not good enough, though. We still are missing, let me draw these over here. Oxygen's going to take those 2 that unshared pair that was here, and it's going to contribute both of them to the bond with carbon. Now, went over it in more detail, but this is called a coordinate bond. It means that coordinate means that oxygen donated both of these electrons to the bond between it and carbon. Carbon donated none. So carbon donates these 2. These are normal bonds, and then this one right here is a coordinate bond. This is actually a triple bond. You can see it because there are 3 pair. Does carbon have 8 electrons? Yes, it satisfies the octet, and so does oxygen. The way this looks like when we draw it, C and O. 2 bonds, and then this one is shown as an arrow, meaning it's a coordinate bond. Oxygen donated all of the electrons, and don't forget our shared pairs, and this is known as carbon monoxide, and CO is the formula. Go ahead and do carbon dioxide right here, and this one right here before. Okay, next 2, back up here to the carbon dioxide, CO2, and it's called carbon dioxide. What you're going to see is 2 double bonds. Basically, that carbon puts all 4 of its electrons into these bonds, 2 in each, and oxygen puts 2 in each, leaving oxygen with an octet, carbon with an octet, and that's 2 double bonds. Down here, carbon, I drew this carbon's electrons with an X so you can see this carbon has 4 electrons, shares an electron with this carbon, and then they each share 3 electrons with 3 hydrogens each. So this is our final structure right here. Carbon's at the center because they can form more than 1 bond, and the hydrogens are on the outside. Okay, last little bit. I'll try to run through this pretty quick. Going from the bottom to the top, I put these in the wrong order, or the hardest order, I guess. Hardest to least hardest. Let's try from the bottom up. We've got nitrogen, and we know that it has 1, 2, 3, 4, and 5 electrons, and then we have 4 hydrogens around it. Okay, that's interesting, because normally we have 3 hydrogens around it. Each hydrogen brings an electron with it, and everyone's happy except right over here. All the hydrogens have 2 electrons, and the nitrogen has has 8, but there's an extra electron over here, okay? An extra electron. What happens to that electron? Well, this polyatomic group has to lose that electron, which gives this group a plus charge, a positive charge. That electron's gone now. And this is known as the ammonium, I think it's 2 M's, ammonium cation. It's a polyatomic ion that we use in ionic bonding. And for your stick structure, it would look like this. And the charge of that is going to be positive, and the formula would be NH4. Don't forget the positive. Great. Now we're going to do the sulfate ion. Sulfur has 1, 2, 3, 4, 5, and 6 electrons, just like oxygen. And, whoops, even oxygen. We got 4 of them. And I'm going to start running out of room, but I'll give this a shot. 1, 2, 3, 4, 5, 6. That one's happy. 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and 6. Sulfur's happy because it has 8. And these 2 oxygens here and down here are happy because they both have 8. But right here and here, these oxygens don't have 8 electrons. So these electrons have to come from somewhere else. And they're going to come from maybe a magnesium, maybe an ion that we know of. It's going to pick up an electron here and here. Okay? We just added 2 electrons, so this is going to be 2 minus. What does it look like when it's drawn in a stick model? It's going to look like this. Sulfur at the center, single bonds, 2 oxygens. Don't forget your unshared pairs. And don't forget the charge. It's a 2 minus. So we had to add 2 electrons to make this happen. This is known as the sulfate anion, and its formula is SO4 2 minus. Doesn't leave me a lot of room for carbonate up here, which is most complicated, so I'm going to actually erase all this, if you don't mind. Oh, you're still there. Sorry, wasting your time. Anyway, I redrew that. Now let's do 1 carbon and 3 oxygens. This is known as the carbonate ion. And we're going to have that carbon right in the middle, and it has 1, 2, 3, 4 valence electrons. And we have 3 oxygens. 1 here, and let's say 1 here. First thing that happens is we know that carbon is going to donate 2 electrons to this bond here. Great. This oxygen atom is going to be very happy. It has its own 6 plus, oops. Let me do that again. It puts 1, 2 here, and then it has its other 2 unshared pairs. It has access to 8 electrons and is happy. This oxygen here donates 1 electron to the bond with carbon, and it has 1, 2, 3, 4, and that's a total of 6 for oxygen of its own electrons. And with this electron, it makes up 7 electrons. Okay, that's not an octet, it's 7. This oxygen is not happy because of this hole right here. And this oxygen donates 1 electron to the bond, and then it has its own 2 unshared pairs and a lonely electron there with a spot for another electron. So those electrons come from where? Well, somewhere else. Maybe a cation. Maybe a magnesium again. Okay? When you add 2 electrons, you end up with a 2- charge. The way this looks in the stick diagram, it's a double bond there. It's a single bond here, and we need our unshared pairs. That one only has 2 unshared pairs. These guys have 3 unshared pairs. Carbon has no unshared pairs. The charge on it, again, is 2-. The formula is CO3, 2-, and the name of it is the carbonate anion. And those are the solutions.